Welcome to this video for the Excel extra credit exercise around variable and fixed cost, break-even point, and expected value. We're going to build in Excel the three assignments that are included in this. So the first thing is to understand fixed and variable costs. We've got a simple example here on the screen of the Shelley Group has a new copier, $700 per month. They have to pay in a lease, let's say. So that is a fixed cost, regardless of the volume, independent of how many times they use the printer each month. They have to pay the $700. So it's a fixed cost. There is also a variable cost of 10 cents per copy. So in addition to the fixed cost, we have 10 cents per copy times the volume that we use. So the simple calculation in Excel to solve for that in the yellow cells here is equals the fixed cost plus the variable cost times, which is our star key, the $5,000 in A16. We can hit enter. Now it is a good practice to always bracket where brackets should be. For example, this multiplication that we're doing in here. So I encourage students to use those brackets, even if they don't affect every time that you use it. It won't always affect, but it'll keep you out of trouble. So then we could do in the next one here for 10,000, it equals the fixed cost plus, wait a minute, something's not happening there. Okay, back up. All right, equals the fixed cost plus the variable cost times the 10,000. And we see $1,700 appear in there. The per cost copy is you find by dividing your total cost over the volume. All right, so in the sense of 5,000 copies, we have a total cost for that month of $1,200 when we add the fixed and variable cost together, considering the volume. And at 10,000 copies, we would have $700 plus 1,000 found by the 10 cents times the 10,000. Right? And if we want to look at our cost per copy, that would be our total cost divided by the volume. And that would be simply equals the total cost, / is for divide, and then click on the volume and hit enter. 24 cents per copy at 5,000 copies. And right below it, we can do exactly the same thing, which is, in fact, we can copy and drag it down because the relationship between this target cell and these two fields is exactly identical to the relationship of this target cell and these two fields. So because it is identical, we can get the dark black box here in the corner, right? So if we mouse over and a field and we come down to this corner here, come on Excel, we mouse down to that corner, the box will turn black, and we could drop and drag that down, and it will just copy this formula relationship into this one. And we see it's 17 cents a copy for 10,000 copies divided by $1,700. Makes sense, right? So why is this a different number? Why is our cost per copy falling? You need to understand this concept. It is basically because, very simply, we're amortizing the $700 here over 5,000 copies and here over 10,000 copies. We could even do the division of that and say, what is that different amortization? Equals $700 divided by 5,000, and this equals the $700 divided by 10,000. And we could see the difference there. It's twice as much, which makes sense. Here, in our 24 cents, we have 14 cents worth of fixed cost amortization. And here in our 17 cents, we have 7 cents worth of fixed cost amortization per unit. Right? The per unit amortization cost is what changes. Very important concept. How do we get our money back? It ties into break-even analysis. It ties into many, many calculations in business to understand of our fixed cost, which is many times an investment in a plant, in a piece of equipment, in machinery, etc. out of that fixed cost, how long does it take to amortize it? Okay, moving down then into calculating expected values. What we have here is a way to look at two different options, investments in capacity, and they could be a variety of different things. It could be a large plant and a small plant. It could be new automated equipment versus old, less automated equipment, or new, less automated equipment. In fact, maybe that's a good example, right? So let's say that option 1 is new, highly automated assembly equipment for a line, and option 2 is new, very low automation, highly labor-based assembly equipment for a line. So the highly automated gives us a very low variable cost because it's not consuming labor. It's highly automated. It'll be a low piece cost per unit. And the very manual process will have much more labor per unit into it, right? More labor, more variable cost each time we build. So let's look. If we take basically the business and say we're not really sure about demand. We're trying to make a capacity decision, but we're not that sure about demand. We have 3 different scenarios that we've come up, talking with marketing and the executive team and really brainstorming this. And we think it could be anywhere from 25,000 to 100,000 pieces that we need per year off this capacity. So very large differences, 25,000 or, right, 4 times that, 100,000, and something in the middle. And our probabilities of those 3 different demand scenarios are 30%. Let me color code these so that you can see them a little bit better. No, I'm not going to bother. Okay, so you've got 25,000 at 30% probability. We've got 60,000 at 40% probability. And we've got 100,000 at 30% probability. Notice that the probabilities all add to 100%. It's very important. They must add up to 100%. And you'll see why when we finish this calculation. So what we need to do is find our total cost, like we did with the calculator here. We're going to find our total cost with the same formula, which is fixed cost plus variable cost times volume. But we have to do that for all 3 volumes. So we're going to find our total cost for option 1 and 2 across 3 different volumes. We'll see our cost per unit across those 3 different volumes, and then we'll drop in this probability factor, and then we'll total. So let's do it. So in Excel, we would basically say equals, remember the formula, equals fixed cost plus the variable cost times the volume. So look at that formula, equals fixed cost plus variable cost times the star key, the volume here. You can hit enter and we're good. Okay, and we have to do that then for each scenario. Whoops, that's a mistake, not times, plus, come on over here, times my volume. Okay, now let's go ahead and move across this equation. We'll do each scenario completely. So cost per unit, if you remember, is the cost divided by the quantity, right? So equals the cost / is divided by the quantity. So we're just working through this. The probability will equal the total cost times the probability equals the total cost, option 2, times the probability. Right, so we can see option 1 fully developed here. I'm going to keep going. If you can bear with me, we'll build this out completely using the same methodology here, right? And I don't want to go too slow for you and bore you, but I'll talk through it each time as I go. So option 1 equals fixed cost plus variable cost times the quantity. Option 2 equals the fixed cost plus the variable cost times the quantity. Okay, then we just keep moving across here. So what is our cost here? Equals the cost divided by the quantity equals the total cost divided by the quantity. And then our expected cost equals the total cost times the probability. And again, equals the total cost times the probability. We have to do it one more time here. So the total cost for option 1, demand scenario 3, equals the fixed cost plus the variable cost times the quantity. Right? Same formula. And the last time for this one equals our fixed cost plus our variable cost times the quantity. Okay, so we got those in. Let's finish up over here. The cost per unit, again, is going to be our total cost / divided by, the quantity. Okay, I'm not sure why my formulas aren't always showing up in the cell as I type. Sometimes they do and sometimes they don't. Excel problem equals our total cost divided by the quantity. And last but not least, we will do with the probabilities equals our total cost times, which is the star key, the percent likelihood, and last but not least equals our option 2 for this scenario times the 30%. And there we go. So we've got these 3 different demand scenarios for option 1 and option 2, the highly automated line and the low automation line, over 3 different demand scenarios. So over a wide variety of demand scenarios, we can now see these, and because of the probabilities that we've extended into it, we can now total these, right, and say equals for option 1 equals my option 1 at the low demand scenario plus my option 2 plus my option 3, $623,000. Now, because the relationship between all 3 of those cells and the total here is identical to the relationship of all 3 of the cells for option 2 and its total, I can use the copy feature here, put my mouse over this corner. Come on, Excel, what are you doing? Oh, you crazy nutty guy. There we go. Okay. Get that darkened black X when I hover over that corner, pull it down, and that will automatically preserve the formula for the new cells because the relationship was identical. Okay, what do we have here now? Very important, right? We don't want to just do the math. We want to understand why this would be useful in business. So I mentioned earlier you could apply it to a wide variety of capacity scenarios and others, different investments that we might make, and say, here are our costs. We've done our job as buyers. We've gone out and sourced this activity. We have confidence in our fixed and variable costs to pursue either of these scenarios. What we don't have confidence in is the volume that we're going to have. And normally you'd see a much higher confidence in the center demand. So in this exercise that I have done many times on a management team and others have done, you have the center scenario often being your business plan, what you really think is going to happen. And sometimes you have low confidence because of legitimate reasons, competitive dynamics, unknowns about a developing market, different factors that are influencing the market, maybe overall global economic instability, whatever it might be, we have low confidence here. I'll say uncharacteristically low confidence. You would often see a higher number here, like 60, 70, maybe even 80%. 80 is kind of high, but see a higher confidence here and lower confidence sometimes on these beltways that are what ifs. They're almost what ifs. But in this scenario, the company has low confidence in the volumes. And what we can see now is that given that we've taken as much diligence as we can with these volumes and these probabilities, and that we know these costs. We know these costs, right? That we can now see that our best choice, given the ambiguity of the situation, is to go with option 1, which is to buy the newer equipment and have the lower piece price. It's not a big difference, right? 623 to 715. So the management team still might have some angst over this and say, well, wait a minute, that's not that big of a reward for taking that risk of of $500,000. So we're going to save the difference in those two, right, on an overall probability. The 715 minus the 623 is $92,000. So we stand in this probability world to save $92,000, and it would never be 92 because all three demand scenarios don't materialize. But we've got a similar situation here. It's not cut and dried. One doesn't really stand out from the other. So we'd probably do some more analytics, look at how tight capital is in the company. How is our cash flow? How is our overall debt structure? Are we willing to take on more debt and to make some more investments for what looks like a nominal benefit here between option 1 and 2? We might do it. We might not, is my only point for calling it out. We also might go back and look at the scenarios. And this is dangerous, right? Because now we're starting to talk ourselves into stuff. Do we really think these rates are right? But we might challenge something and say, are these variable costs really accurate? We probably have a pretty good feel for what the line is going to cost. But we might go back and say, this $100,000, is it really $100,000? It sounds like an awful round figure to me. Somebody swagged this number. Let's dig a little deeper, peel the onion back, and see what the real number is. And you'll see this as a manager. Whenever somebody throws round numbers at you, you say, whoa. This is an estimate. If it's a close scenario like this, we need to dig in and say what's really going on here, because the number is not 500,000 and it's not 100,000. That's an estimate. And it's not $2 and it's not $10. Those are estimates too. Let's dial this in tight, because this scenario is not really, with the estimates, it's not pointing to a clear enough picture. We're too close on this. Let's say, for example, that there was a mistake in the estimates and somebody comes back and says, no. I didn't mean $10. There's a mistake in our stuff. I'm glad it got rechallenged by management. It's not $10 per unit. It's $5, right? All of a sudden, our options change. You saw how that jumped all of a sudden, right? Option 1 cost of $623. Now option 2 is $407. So we have justification to not make a $500,000 investment. The numbers say, don't do it. You're going to spend money, you're going to put more debt into the company, higher fixed cost, more risk to the business, and you shouldn't have done it. The more manual process would have been fine. And there's other things that go into that, right? Now, like more manual processes are much more flexible. Highly automated processes are inflexible. They're all programmed in and hardwired into automated equipment. They're less easy to budge and manipulate. Manual's easy to change. All right. I wanted to walk you through the interpretation of that, because regardless of what you're studying here in school, you can see that we can come up with some numbers as a decision support for a very important decision, but the numbers need to be real, and it's fine to go back and challenge those and to reach deeper into the numbers when the answer is a little bit ambiguous or doesn't point to a clear direction, and to say, wait, let's look deeper into this stuff. The probabilities, can we dig deeper into why we have such similar probabilities? Can we take another pass marketing at this and try to get more confidence in one of these scenarios? So there's lots of ways to have an iterative approach to using these tools. The danger is to avoid that bias starts coming in as we iterate, right? We can't have bias in these numbers. That's the fudgy factor. Okay, last thing, the break-even point. Why do we care about break-even point? Because we use it everywhere. It helps us understand profitability. So break-even point is a very important, simple financial analysis that's done all the time around the world in businesses, right? A very important number. This BEP, break-even point, is targeted around a quantity that we must achieve to break even on a capacity investment. So in the example here, Phillips, he owns a fireworks store. His costs are $1,200 per month, fixed cost. And you see in the formula here, fixed cost, FC, right? And Phillips thinking about expanding. He's going to buy another store across town or in the next state. He's going to buy some more real estate. His fixed cost is going to go up. And he wants to compare his current situation to the expanded situation. He thinks that when he expands into another state, his volume is going to be high enough that he can negotiate a lower variable cost per unit. So he wants to run the numbers and just see where's his break-even point in the two scenarios. So his current scenario, he has $12,000 a month in all of his fixed costs. Let's just make it simple and say it's a building lease. And his revenue per unit on average is $25, and his variable cost per unit, his purchasing cost per unit, is $8. So we can come into this yellow cell and do the simple math, equals, look at the formula over here, fixed cost, which is $12,000, divided by the difference of his revenue per unit and his cost per unit. So we should put that in brackets, right? And put revenue per unit minus the variable cost per unit, another bracket, and hit return. So today, Philip needs to sell 706 units every month before he starts making money. He's losing money. He's in a loss overall for the month until he gets to that 706. If he expands his business, his fixed cost is going to go up, remember, and his variable cost is going to go down because he's confident he can negotiate a better price for the fireworks that he sells, that he can get that from $8 down to $5. So that's significant. So he should be very confident of that. It's dangerous to be just optimistically assuming you're going to be able to negotiate that. He should have already negotiated it. He needs a good reason to think that that cost is going to fall. Let's put the math into Excel so you know how to do it. So that would be equals his new fixed cost, remember in the formula, break-even point being quantity, his new fixed cost divided by, right, divided by, and then put into brackets the math. The 25 selling price minus the $5 variable cost, close off the bracket, hit enter, and away we go. In his new business, he's going to need to sell 1,000 pieces per month before he gets to break even. And you might look at that and say, well, why would he expand if he has to sell more to break even? Well, that's not the right way to look at it. He's expanding his business. Of course, he has more fixed costs, and he needs to expand if he wants to grow his business. But we can run some other ratios or look at this and think behind the numbers, right? And say, well, his sales, right, or his total cost structure went up by some percentage, and his break-even point went up by some percentage. But because his variable cost per unit fell, his overall profitability, once he hits his break-even, is going to be tremendous. It's going to be tremendously enhanced, right? So he is adding, if you think of this, step back and look at what he's done from a business point of view. Just go to 20,000 feet and look at this picture here. Don't get tripped up by the fact that his break-even went up. If he's a good businessman and he has done a sales plan that shows this is all justified, the market is real, and he's going to expand his sales, his profitability is going to go up as long as he can hit that break-even point, right, and get a good percentage of revenue above it. He's almost certainly going to enhance his profitability, right, because he knocked a major dent into his variable cost structure. So there you go. That's break-even point. I hope we were put it into context a little bit so you can see why this is useful, why it matters. And that concludes the tutorial for our Excel extra credit assignment.